There are many different definitions of acids and bases, but they tend to go together. The first we're going to talk about is Arrhenius, and then later on we'll talk about Bronsted-Lowry. In your textbook, they also talk about Lewis acid and bases. We will be focusing on Arrhenius and Bronsted-Lowry. An Arrhenius acid increases the concentration of hydrogen ions, so H+ in an aqueous solution, which just means in water. The molecular compounds with ionizable hydrogen atoms. We're using the hydrogen from an acid to ionize water to create the solution. Because acid molecules are polar enough, the water molecules will attract one or more of those hydrogen atoms from the acid, and I'll show that in a few examples. But again, the more polar something is, the more acidic it will be. For my two examples, and you only need to write one in your notes, I have a strong acid in the first example with nitric acid here, HNO3. The acid is going to donate its hydrogen to H2O, which creates H3O plus or hydronium. And then we're left with a nitrate ion. And because it's a strong acid, I only use the single arrow. But again, we're taking a proton from our acid, giving it to the water to create that hydronium. For the second example I have phosphoric acid, H3PO4. One of the hydrogens is going to donate to water, which creates our hydronium, and then leaves us with a polyatomic ion. And it's one that's not on your list of the 22, so I'm not going to test you on it or anything. It's just a great example for the weak acid. For Arrhenius bases, they increase the concentration of hydroxide ions, which are OH -1, and again in an aqueous solution, that means in water. They tend to be ionic compounds. They'll contain a metal cation and a hydroxide, which is your anion. They'll dissociate when dissolved in water because they are ionic. So, dissociate with the ionics. For the examples, I have sodium hydroxide, which is a strong base, and because it's a strong base, it will dissociate. It is also ionic, which is why it dissociates. It goes into Na+1, which is sodium, and then its charge, and hydroxide, which is a -1 charge. Some weak bases, especially with ammonia. Ammonia is not an ionic compound, it's covalent, or it's a molecular compound, which means it will ionize. In this case, water is going to donate one of its hydrogens to NH3, which creates ammonium, NH4, with a +1 charge. And then after it donates, we're left with a hydroxide ion. Again, keep in mind that if it is a ionic compound, it will dissociate, but in the case of ammonia, it is going to ionize because ammonia is a molecular compound. In the next video, we'll talk about Bronsted-Lowry bases, and then beyond that we'll go into amphoteric compounds, which will help explain that equation, the second one here, a little bit more.